Hey, today I'm going to review the FY6900 Frequency Generator. So on YouTube I see a lot of videos reviewing this particular frequency generator, but they're not going in depth. Basically they're just reviewing everything at 10 kilohertz, and this thing goes up to 60 megahertz, and none of them actually brought it all the way up to that 60 megahertz. So today I'm actually showing you all the frequencies that I can at the maximum frequency that you could get from this. So basically this frequency generator comes with the one probe that you can just stick straight to your oscilloscope, and you have two smaller probes that you can just hook up to your circuits, whatever you need to do with that. And I have the Rigol DS1054 as my oscilloscope that I'm going to be using to probe this to see what the frequencies are. So to turn this thing on, there's a switch in the back. Just flip the switch and it will always turn on. If you want to turn the thing back off again, you could turn this off to do like a standby mode, or just turn the thing off directly in the back. So right now this is a sine wave at 10 kilohertz. I'm just going to plug this into channel 1 and let me... And there you go. 5 volts peak to peak at 10 kilohertz. Alright, now I'm going to increase the frequency to So this is straightforward. If you want to change the frequency, you click the top one, change this frequency. If you want to change the amplitude, switch to the bottom one, it goes from there. So at 500 kilohertz, I can switch the amplitude to, let me see, the maximum. So that's 10 volts peak to peak, and according to the oscilloscope, it's 10.2 volts peak to peak. That's good. Going all the way to the maximum this thing could do, and that is 24 volts peak to peak, and on the oscilloscope is showing 24.4 volts. Cool. Gonna bring this down to 5 volts peak to peak because I like that one. And let me go ahead and increase the frequency to 10 megahertz. And at 10 megahertz, it's 5 volts peak to peak, no problem. Let me change this up to how far this thing could go. And at 10 megahertz, you could get 23.4 volts peak to peak on the oscilloscope. Bring this back down to 5. Gonna increase the frequency to 30 megahertz. And as you can see, it's been a good 5 volts peak to peak still. Going to the maximum. It will not go any higher than 5 volts peak to peak after you get to 30 megahertz. Maxing this thing out at 60 megahertz. You see it's attenuated by a little bit. It's now at 3.8 volts peak to peak. But still looks like a good sine wave. Going to the offsets, I am bringing the offset up a couple of volts. And everything still looks the same. Let me go with the offset up here. Once you go at a higher offset, you get some distortion. And this is at a 2-volt offset. And that's the maximum you can go, is a 2-volt offset on the positive and negative side. Alright. Let's go to the duty cycle. Since it's a sine wave, there is no duty cycle. And go to the phase angle. You can change the phase angle by a couple of degrees, go by 0.0 degrees. There's not really a difference on there. So you can't really tell the phase angle unless I have another identical sine wave on this. Alright, now I'm back at 10 kilohertz at sine wave. And I'm going to change the waveform to a square wave. Looks like a typical square wave at 10 kilohertz. Looks nice. And so let me go ahead and increase the frequency. So you see some voltage spikes right up there. Let me just zoom that in just a little bit. Alright, so going up to 1 megahertz, and you see more of a voltage spike, the start and end of the duty cycle. Still looks like a decent sine wave. Now I'm at 2 megahertz, 3 megahertz, you see the distortion getting a little bit greater. 4 megahertz, 5 megahertz, 6, 7, 8, 9. Now it's more apparent the distortion on this. 10. This thing says it's rated for 10 megahertz on the square wave, and you can see how much distorted this thing is. 11, 12, 13, 14, 15, all the way up to 20. Now this becomes more of a trapezoidal wave. And then at 25, it's no longer a square wave. And then this has the ability to keep going, and the square wave just turns into a sine wave once you go beyond 30. Now going at 1 megahertz, I'm going to see how high the amplitude could be on this. So switching to amplitude, and you have 10 volts peak to peak, and I see 10 volts peak to peak on the oscilloscope. Going to 20 volts peak to peak, I see 20.8, still good. And now 24, I see 25 on the oscilloscope. That may be because of the voltage spikes, that's why it's higher than usual. Now I'm going to keep it at 24 volts peak to peak on the signal generator, and I'm just going to increase the frequency. And so that is still 25 going up to 5 volts or 5 megahertz. Now we're at 10 megahertz, and now the square wave turns into a sine wave. It's not usable at this amplitude. So let me see, turn this down to where it becomes usable. And at 5 volts peak to peak, that's when it looks good. Everything else is distorted. And the lower the frequency, or the lower the amplitude, the better it becomes. Now, at the 24 megahertz, what is it? At what voltage does it look good as a square wave? And dropping this down to this is 9 millivolts, or 0.9 volts peak to peak. Going into the millivolts range. And there's so much noise on this, so right now I'm at 90 millivolts peak to peak, and you could see for yourself this is not looking good. Alright, let me reset this to... Alright, so we're back at the 10 kilohertz at the normal square wave. Now I'm going to change the offset. I'm going to go in 1 volt increments. And no problem with the offsets. I could bring this offset all the way up to 12. The issue is it does become attenuated at these higher offsets. And so I'm getting 3.4 volts peak to peak when I'm trying to get 5 volts. Now, let me change the frequency. To 5 megahertz. And let me do the same thing with the offsets. I'm going to start bringing the offsets up by 1 volt. And that is 2.5 volts at 5 volts peak to peak. I'm going to the max offset. Again, it gets attenuated to 3.2 volts. And let me increase the frequency. My oscilloscope can't pick this up, so... Oh, never mind, I can. Sweet. And it just reset on me. The offset completely dropped off once I hit 24 megahertz. Okay. Now let me go to the duty cycle. That's a square wave, so I can't do no duty cycle. Okay. Again, I can't do this phase angle unless I have 2 hooked up, so I'll show that later. Going to the next waveform, rectangle. Now I could do the duty cycle. So I could imagine the rectangle is going to be exactly the same as the square wave, except for I could now change the duty cycle. And now the duty cycle has been increased to 75. It's like a typical Now let's see at a higher frequency. Let's go to 10 megahertz and let's see how the duty cycle is. So I'm going to increase the duty cycle, and it no longer becomes a square wave, but more of a spike. Or putting this back at 50%. You could imagine everything else is going to be more distorted at the end, but I'll bring you up to the 24 and change the dB cycle from there, and you're going to see how bad this gets. Alright, the next is the Trapezoidal. I currently have it at 10 kilohertz. And I'm going to change the rise time. And if you want to click the fall time, then you click the same thing and you can go ahead and click the fall time. So I maxed it out, and there you go. Now, how does it look at a higher frequency? I'm just going to drop this down to, then bring it up to 1 megahertz. What just happened? Okay, so the trapezoid does not like 1 megahertz at all. Let me change the rise and fall time to something more reasonable, I guess. So by decreasing the rise and fall time below that, then it may be able to get to 1 megahertz. You're not going to have the offset that you want. This thing dropped all the way down to negative, so you have to deal with that as well. Moving on to another waveform. This is basically the triangle waveform, but at a 0 offset. And multiple other YouTube videos actually went more in depth into all of the other waveforms. I'm just going to give you the basic ones and at the max frequencies. I'm also going to sweep this thing up from 10 kilohertz all the way up to 60 megahertz because everybody did their sweeps from less than that, so I'm just going to go greater than that. So selecting through all the pre-programmed waveforms, there are a lot of them. Cool thing is you could get, and you could program your own arbitrary waveforms, which is nice. I'm not going to show you how to do that because there's multiple other videos that show you how to do that from this, so I'm just going to keep it simple. So there are a total of 64 arbitrary waveforms on top of the pre-programmed waveforms. So you can program up to 64 different waveforms on this oscilloscope, which is awesome. And since you have waves selected, you could easily switch between the waves just by going through this, which is much easier. I wish there was just a reset button, but if there is, I don't know about it. Other than that, we're going to go to sweeps, and so click the sweep button, go to the Yes, frequency, start time. So right now I have it at 10 kilohertz. I'm going to bring this up to 60 megahertz. And let me go to the time. And I'm going to do this sweep in 100 seconds. And 200 seconds. I'll fast forward this, but that way it's not going to be a quick linear thing. You can change the modes. I'm just going to keep it on where it is. And here we go. Alright, I'm getting impatient. I'm just going to stop this right here. Go back to the start. I'm going to keep it the same. Let me change the time. Instead of 200, bring that down to 10 seconds. And here we go again. Sweet. Alright. Now let me change the mode to logarithmic, and here we go again. Let me change the amplitude. Gaps will sweep the amplitude, which is nice. So start from 1, end at, let's make it 24. 10 seconds, back and forth, and go. Alright, hope you enjoyed my review on the FY6900 Frequency Generator. If you have any questions, please leave a comment and I'll try to get back to you as soon as I can. Thanks for watching. Bye.